We've all been there, haven't we? You're deep in your code, you've got your AI helper running, and you ask it something, maybe refactor a component, debug a little function,
Yeah.
and it just completely misses the point.
Oh, yeah.
Gives you old code, or it's like it's got digital amnesia. Forgets everything you just told it about the project structure, like 5 minutes ago.
Digital amnesia, I like that. It's spot on, really. You're in the zone, things are clicking, and then the AI just, yeah, loses the plot entirely. Super frustrating.
Exactly, and that frustration, that constant need to re-explain things, that's really what we're diving into today. Our goal is basically mastering AI context so we can all be more productive, because the core issue is that lack of, continuous context. These tools often feel like a blank slate every time you prompt them.
Which wastes so much time.
It really does.
And it's a known problem, right? People are thinking about this. There's even this kind of futuristic idea floating around called MCP servers, Model
Yeah.
Context Protocol servers. The idea is these servers would let AIs automatically tap into a project's full context, like really understand it. Think of it like a permanent memory for the AI, deep understanding.
Yeah, and it's important to say, while these, dedicated MCP servers themselves might still be mostly concepts, maybe just around the corner, the ideas driving them, those are incredibly valuable right now.
Mm.
They give us a sort of roadmap for how we can today teach our current AIs, ChatGPT, Gemini, Claude, whatever you use, teach them to grasp our projects on a much deeper level.
Exactly. So that's our mission for this deep dive. We're going to unpack 10 practical techniques, all based on those MCP ideas, things you can actually use now, to give your AI a better memory, basically, a clearer picture of your project, which should, really boost your productivity, get the AI working with you, not against you.
So think of this as just a calm, curious look at how we can make AI truly work for us, moving beyond those simple one-off questions towards something more like an informed partnership. Let's dig in. Okay, so first up, something really fundamental, the project structure itself. This first idea comes from the concept of a file system MCP. Imagine an AI server that could just read and understand your whole project directory.
Know where every file is automatically.
Exactly.
So how do we do that now, practically speaking?
Well, it's actually pretty straightforward. Before you ask the AI to do something involving files, give it the structure first. You can just run a tree if you're on Windows, or else void.R on Mac or Linux.
Okay.
Copy that output, paste it right into your prompt. It's like, here are the blueprints.
Gotcha. So you'd say something like,
Yeah, you could say, here's my project's directory structure, then paste the tree output, and then follow up with, okay, I just moved button.tsx from circuit components over to circuit design system atoms. Based on the structure I gave you, find all the files and circuit pages using this button and rewrite their import paths.
ah, okay, you're giving it a concrete map. No guesswork.
Precisely. So why is knowing that file location so crucial for the AI?
Well, without that map, it's just guessing, right? Especially in a big project or one that changes a lot. Those guesses about where files are, that leads to wrong suggestions, broken code,
Yeah.
just misunderstanding what you even want. Giving it the structure avoids all that hassle.
So basically, it prevents AI from making assumptions about file paths.
That's the core of it. Okay, so that's where things are. What about how they got there? The history.
Good point. That leads us straight into Git context.
Yeah.
This comes from the Git MCP idea, an AI that knows your commit history, branches, recent changes, the whole story of the code.
Like it's been pair programming with you the whole time.
Kinda, yeah.
So the practical step here is running commands like git log or git diff locally, and then just copying that output into the prompt.
Exactly. You give the AI a clear snapshot of the project's evolution.
Okay, so an example might be,
You can say, here's the commit history between tag v1.2.0 and the current main branch.
yeah,
Then paste the output of, say, git log v1.2.0's.head one line. Then ask, based only on these commits, please draft some concise release notes for v1.3.2. Categorize them into new features, bug fixes, and improvements.
nice. You're giving it the actual changelog, not just bits of code. So how does this historical context make the AI a better collaborator?
Well, it shifts it from just generating code to being more like a knowledgeable teammate.
Okay,
It sees the why behind changes, the problem solved, the direction you're heading.
right.
So the code it suggests, or the summaries it writes, they're just much more relevant because it gets the intent. It lets AI understand project evolution and recent changes.
Yeah, which is crucial. Which leads nicely into the next idea, creating a kind of memory bank.
Ah, yes. the memory bank. The concept, the memory bank MCP, was this server that holds all your project decisions, your coding conventions, architectural rules, and it remembers them across sessions.
Dreamy.
Right. No more repeating yourself.
Definitely the dream. So how do we mimic that today?
You can use features like custom instructions if your AI tool supports them.
Mhm.
Or, and this works anywhere, just start every conversation with a really clear system prompt.
Okay.
Lay down the law from the start. Establish the project's DNA for the AI.
So a system prompt might look like.
Yeah, like right at the top, system prompt. Okay, for this whole chat, stick to these project rules. 1, language is TypeScript. 2, use Axios for all API calls. 3, React components are function components with hooks.
Clear rules.
Now, help me create a user profile component. You know, I have to admit, I still wrestle with prompt drift myself sometimes. Keeping the AI consistently on track can be genuinely tough.
Well, for sure, it happens.
But this memory bank approach, setting it up,
Yeah.
what's the biggest benefit? Does it outweigh that initial effort?
That's a fair question. It does take a little setup. But think about how much time you spend correcting the AI later, right? Re-explaining conventions, fixing code that doesn't fit the pattern. That drift adds up. So this memory bank approach, it front-loads that effort, but it pays off over time with consistency.
It ensures consistent AI behavior across all interactions.
Exactly. Consistency is key.
Yeah.
And speaking of keys, knowing how the pieces connect.
Absolutely. Which brings us to analyzing code relationships. This is inspired by the knowledge graph memory idea, an AI server that automatically maps out all the dependencies. Which functions call which components use others.
Yeah.
Like a big interconnected web.
Wow, that would be powerful. How do we approximate that?
We can use our IDEs, actually, features like find all references or go to definition.
Ah, okay. Use the tools we already have.
Right. Get that dependency info and then feed it to the AI.
So you could say,
You might prompt it like this. Okay, I'm refactoring the calculate price function in utilscalculations.js. My IDE shows it's used into components card.js, page checkout.js, and service order service.js. Based on that, what are the potential risks here? And what steps should I take to avoid breaking things during the refactor?
okay, so you're giving it the dependency map. Why is understanding these links so important for the AI?
Because it lets the AI predict the ripple effects.
Mm-hmm.
If it knows everywhere that calculate price function is used, it can warn you before you break something downstream.
Yeah.
It can suggest safer ways to refactor. It shifts it from just coding to being more preventative. It helps AI foresee impact and avoid breaking things.
Which is always good, less debugging. What about external info, like docs?
Yeah, good question. Technique 5 is about retrieving web and API documentation. This comes from the Fetching Context 7 MCP ideas. The vision was an AI that could just pull the latest docs for any library automatically.
Instant, up-to-date info. Okay, so for now, it's on us.
For now, yeah.
Yeah.
Instead of hoping the AI finds the right docs, or worse, makes something up.
Hallucinates.
Exactly.
Yeah.
You go to the official docs yourself, copy the relevant bit, could be text, could be a code example, and paste that directly into your prompt. You're curating the info.
Okay, so like, I'm using chart.js version 4.4. Here's the official docs snippet for donut charts. Then you paste the snippet.
Right. And then, based on this specific documentation, write the code for a donut chart showing this data. Sales, 60, marketing, 25, dev 15.
You're giving it the ground truth. How does providing that specific curated info prevent those AI hallucinations?
Well, it directly counters them. You're providing concrete facts from a trusted source. The AI doesn't have to guess or rely on possibly outdated training data.
Right.
It has the authoritative answer right there, dramatically boosts accuracy and reliability. It provides concrete, factual knowledge for the AI.
Makes sense. Less time debugging the AIs on the
Creativity.
than the creativity.
Exactly. Okay, next up, leveraging intelligent search. This stems from the Tavily MCP concept, a specialized search engine for developers. Understood code, problems.
That sounds amazing. So how do we get close to that now?
If you're using an AI with web browsing built in, like Gemini or the latest chat GPT,
Yeah.
you can guide its search. Don't just ask a generic question. Tell it how to search. Instruct it to search, synthesize, and pull answers from reliable sources only.
Ah, okay. Like giving it research instructions.
Pretty much. So you could say, I'm getting a CORS, pre-flight request did not succeed error with AWS Lambda and API Gateway. Please search the web, specifically looking for official AWS documentation and reputable tech articles on configuring CORS for this setup. Then summarize the top 3 common solutions you find.
Okay, so it's targeted problem solving. What's the key difference between doing that and just, Googling it myself?
The synthesis part is key.
Mm-hmm.
The AI isn't just giving you links.
Right.
It's reading multiple sources, figuring out the common patterns, the most frequent fixes, and presenting a concise summary.
Distilling it down.
Yeah, it's a focused, solution-driven search, not just information retrieval. It's a focused, synthesis-driven search, specifically for solutions.
That could save a lot of time sifting through search results.
Definitely. Okay, number 7, connecting personal notes.
Hmm.
Inspired by Obsidian MCP, the idea of an AI plugging directly into your personal knowledge base. Your notes, your requirements.
Your brain, basically.
Sort of, yeah.
How do we do that practically?
You just copy and paste. Open your Notes app, Obsidian, Notion, plain text, whatever.
Okay.
Find the notes relevant to what you're working on, copy them, paste them into the prompt.
Give the AI a peek into your specific thoughts.
Exactly. So you could write, here are my notes on the login page requirements,
Right.
then paste your bullet points, email password fields, standard email validation, password HRs, Google sign-in button,
Mm-hmm.
then ask, based only on these requirements, generate the basic HTML and CSS for this form.
How does giving it these personal notes, which aren't really code, how does that personalize the AI's help?
It makes the output truly specific to your project, your thinking. Often, the little details, the nuances, the specific constraints, they only live in those notes.
Right.
Giving the AI that context helps it generate something that actually matches your vision, not just a generic template. AI gains insight into your unique project specifics and thoughts.
That's really powerful for getting tailored results. Now, what about really complex tasks?
Good transition. Let's talk about applying sequential thinking. This comes from the sequential thinking MCP idea, an AI that automatically breaks down big problems into logical steps, like how an experienced developer thinks.
Okay. How do we encourage that?
This one's actually super easy to apply and really effective. You just explicitly ask the AI to think step by step or break down the problem first.
Just tell it to slow down and show its work.
Pretty much, it prompts it to use a more structured approach and actually explain its reasoning.
So an example.
You could say, I need to build a shopping cart feature. Please think step by step and outline a detailed plan. Include 1. The data structure for the cart. 2. Key API endpoints needed. Add, remove, update. 3. The main client-side logic.
Ah, okay. Forces it to be methodical. Does asking it to think step by step actually make the AI, smarter? Or is something else going on?
It's less about making it intrinsically smarter and more about forcing it to show its process and follow a logical path.
Okay.
It reduces the chance of it jumping to conclusions or skipping crucial steps.
Right.
It guides the AI towards outputs that are more structured, more reliable, easier for us to understand and verify, less rework. It guides the AI toward more structured, reliable outputs.
Better, more trustworthy code. Makes sense.
Okay, Technique 9 deals with something critical, handling environment variables securely. Based on the Involved MCP concept, an AI server that helps access secrets and environment variables without ever exposing them.
Super important. And the rule today is absolutely critical, right?
Paramount.
Hmm.
You never, ever paste API keys, passwords, any secrets directly into an AI prompt. Full stop.
Never, ever. So what do we do?
You instruct the AI to write code that retrieves secrets from environment variables using standard methods, like process.env in Node or os.getInv in Python.
Okay. Tell it how to get the secret securely.
Exactly. So a prompt might be, write a Python function to call the OpenAI API. Do not put the API key in the code. Read it from an environment variable called OpenAI. If that variable isn't set, the function should raise an error.
Perfect. Keeps the secret safe, out of the code, out of the prompt.
Ooh. Imagine securely managing secrets for like 1 billion AI queries automatically, never risking exposure. That scale is mind-boggling.
It really is. But even on our scale, why is the security aspect just so vital right now?
It's just fundamental secure coding practice. Hard coding secrets or accidentally pasting them into a prompt, that's how major breaches happen.
Yeah.
Compromised accounts, stolen data. Yeah. So teaching the AI and ourselves to use environment variables properly protects that sensitive info. It prevents those potentially catastrophic, really costly mistakes. It's about building secure habits. It protects sensitive information, preventing costly data breaches.
Absolutely priceless in the long run. Okay, one more.
Last one, number 10, integrating API contracts. Inspired by AP-Spec MCP, an AI that could read, say, an Open API or Swagger file to know exactly how an API endpoint works.
The precise structure, requests, responses.
Exactly.
So practically, we copy the relevant part of our spec file.
That's the idea. Find the specific endpoint definition in your OpenAPI.json or Swagger.YAML. Copy that whole definition, the YAML or JSON block. Paste it directly into the prompt. Give the AI the undeniable contract for that endpoint.
Okay, so I need a JavaScript function. Here's the OpenAPI 3.0 spec for the user endpoint. Then paste the spec log.
Right. Then, based strictly on this spec, write a fetch function called getUserBy that takes user-id. Make sure it handles the 200 success response and the 404 error case correctly, as defined.
Got it. How does giving it that explicit API contract make the interaction more precise?
It just removes all the ambiguity. The AI doesn't have to guess about parameters or what the response looks like or which status codes mean what.
It has the blueprint.
Exactly. The code it generates for talking to your API will be perfectly aligned with your backend. Fewer integration bugs, smoother development. It gives AI an exact blueprint for API communication. So that's 10 techniques, 10 ways to give our AI better context, all inspired by those future-facing MCP server ideas. And the big idea, the main takeaway here, is pretty simple, really. You don't need to wait for those futuristic servers. You can effectively be the MCP server for your AI right now.
That's it, exactly. The power isn't in waiting for new tools, it's in how we use the tools we have. Adopting that context-first mindset every time you write a prompt, it changes everything.
And when you start doing this, providing file structure, Git history, that memory bank system prompt, the API specs, you will see a difference, a really noticeable difference. The quality of the AI's output goes way up, and your productivity. It really does get a significant boost. It's about having a richer, more informed, and just more reliable conversation with these tools. And maybe a final thought to leave you with. What if, by giving AI this deeper context, we're not just making the AI more useful, but we're also subtly changing how we approach problem solving, how we structure our own thoughts about the code?
That's deep. But yeah, maybe. I'd say just try one or two of these techniques. Next time you're working with an AI, pick one, give it a shot, see how it feels, see what happens.
Thank you for joining us for this deep dive on mastering AI context. We really hope it helps you build smarter, build faster, and maybe with a little less frustration.